Hi everyone, welcome to the Laser Channel. My name is Greg, and in this video I'm going to see if this Atomstack Rotary unit is compatible with the Ikier laser machine. Welcome back. Thanks for joining me for yet another great video. Did you know that this video topic came from one of you viewers by leaving a comment down below? I do read those and I do add them to my scheduled list of videos to record for all of you. Let's get started and connect the rotary unit up to the K1 laser machine. I'm going to start by showing you the cable that I have connected to my rotary unit. By the way, the cable that I'm using on this rotary unit is the same cable that I use on the Atomstack laser machine that I have. Let's check out the connector on the bottom side of the rotary unit, and we'll see that the cable going into the connector, all of the wires go straight in. None of the wires cross over before going into the connector. When we take a look at the machine side of this cable, we'll see the same thing. All the wires are running straight into the connector. None of the wires cross over. At the time of this filming, I do not have the correct standoffs for the K1 laser machine. So as a temporary substitute, just to elevate the machine off the work surface, I'm going to use several pint glasses placed upside down on my table as this makeshift stand. I've got my leg extensions installed on the machine. You know, I do realize that this is not the most ideal situation, but using these pint glasses really is an effective way to stand the machine up off the work surface so I can place the rotary unit inside. Now that this is complete, I'm going to show you the wire cable connection between the rotary unit and the laser machine. I'm going to make this cable connection while the machine power is still off. This connection can be found behind the main controller board, and it's this motor here that we're going to disconnect. That motor, of course, controls this direction of motion on the machine that we do not need when running a rotary. All I need to do is remove that cable from the motor, and that loose cable that we just pulled off, I'm going to grab the end of the rotary attachment cable and I plug those two together. And these fit together very nicely once I flip the connector around to face the correct direction, and it snaps in, and I've got plenty of room on that cable to move the rotary attachment around in the workspace as needed. I'm now ready to connect the machine up to the computer, and we're going to take a look inside LightBurn on what needs to be done to configure the rotary unit up to the machine. Inside LightBurn software, I am already connected to my laser machine, and in order to enable the rotary, I want to make sure that I've got a little section here. It's currently blank, so to turn on the switch for activating the rotary unit, I'll head over to Edit, Settings, and there will be a little checkbox right here, Show Rotary Enable on Main Window. I'll click OK, and now we have that little section there that shows up, and I can go up here to the rotary setup, and I just want to check a couple basic things right here. I want to make sure that I'm on roller and that I've enabled the rotary unit and that it is going to be on the y-axis. We're going to loop back to this. Right now, we just want to make sure that we can get some movement out of this rotary unit before we worry about any of these other numbers. This all looks good, and I've got the start from in the current position, and really this job origin doesn't matter at this time, but what I want to do is hit the move keys, and we'll see if we've got some movement on this rotary unit. And look at that, we've got movement. It's nice and smooth, and it's not jerking or jittery. So this all looks good. We've got movement, and the next thing that I'm going to share with you is how to make sure that when you tell LightBurn software to move a certain distance, the rotary unit is actually making that same distance. I call that a rotary calibration. The reason why it's important to calibrate the LightBurn software up to the machine hardware is if I don't do this, whatever graphic I engrave on a jar will have a tendency of being far too wide or far too narrow. So to overcome this, what I'm going to do is measure the diameter of this jar, and using a calculator in LightBurn, I'm going to find out what the circumference is of this jar. I'm going to draw a box in LightBurn that is that distance of the circumference. And what I want that to do when I engrave this jar is I want the two ends of the box just to meet. Now this means that anything that I send out to the machine, once this is calibrated, that it will be the correct proportions. After that, I'm going to take a number and I'm going to do another sample engraving on the jar, and this way I'm going to find out whether or not I need to mirror the image. To do these sample engravings, we'll see that my jar has some blue painter's tape on it, and what I like to do is use just enough power to mark or score the blue painter's tape without cutting through it. This method does have a little bit of trial and error, and this is a great way to very quickly engrave and see what you're doing without actually having to engrave the glass. And if I run out of blue painter's tape, I can easily remove this tape and reapply a new piece. Now with that covered, it's time for me to take a measurement of the diameter of this jar. And I've got that noted down. And let's hop back into LightBurn software and take a look at that setup menu one more time. The other thing that I want to do before I jump into LightBurn software too is I do want to take a measurement of the roller diameter on my rotary unit. I've got that measurement and I'm going to jot that in my notes off to the side. Now I'm ready to jump into LightBurn. Back in LightBurn, I'm going to navigate to the top of the screen to Rotary Setup. And this is the menu that we just saw before where we have this set to roller. Of course, we have the rotary enabled and we're still on Y-axis. This is always going to be the setup when using this type of a rotary attachment. Now it's time to come over to these numbers here. I'm going to start with the roller diameter. This is going to be that last measurement I took of the roller, and for me, I measured out 16 millimeters. I'm going to loop back to this millimeter per rotation. This is going to be what we adjust to make sure that the ends of our box that we engrave on the jar meet up perfectly. Now that calculator that I mentioned earlier, my glass jar measured at 69 millimeters. When I enter that in, I automatically get the circumference is updated. So this number here is what I want to highlight, this 216.77 millimeters, and I'm going to right click and I'm going to copy that. Now this is all I need from this screen for now, and I can close that out. And step one, I want to draw that box. I'm going to make sure that my padlock is unlocked, and I want that height to be the circumference of the jar. So I Control V to paste that number in, and this width of the box only needs to be about 2 millimeters. That looks good. I'm on layer 00. When I navigate to cuts and layers, we'll see that I have a speed of 25 millimeters per second with a power level of 10%. I don't need a whole lot of power here. Again, I just want to mark or score the blue painter's tape. I have the laser module positioned near the edge of the glass, but yet the auto sensing, the autofocus switch right by my finger is still on the glass. I'm going to go into LightBurn and hit that autofocus. With that set, I'm going to reposition the laser module off to one side. Now, I have the crosshairs offset set up in my machine, so the machine is going to start where the crosshairs are. And let's hop back into LightBurn and see where I have the origin of the work to start. I've got the job origin here set to the far left in the middle. And the first thing I want to do is just hit the frame button and make sure that I don't get multiple revolutions of that glass jar while it frames out. And the other thing that I'm looking for is making sure that the jar only rotates like a quarter revolution or a half revolution. Remembering that the box that I drew is supposed to wrap all the way around the glass jar where the ends of that box will just barely meet. That looks correct, and let's jump back into the rotary setup at the top of the screen. And to skip through all the trial and error of getting the ends of the box to meet, of course I pre-tested this before making the video, and for my machine and my setup, I found this millimeters per rotation. If I used 40.5, that got the ends of the box to basically just meet up, which is what I'm looking for. Now, if you're finding that the box that you do, that the ends of the box are overlapping too much, or that glass jar is just rotating far too much, you'll want to reduce this number. And the opposite end, if you do this engraving and you can't get the ends of your calibration box to meet up, you'll want to take this number and make it a little bit larger. This looks good. I'm going to grab a pair of safety glasses, put those on, and hit the start button, and we'll check out the results. The neat thing about this is it does not take very long at all. Here's a nice close-up of that glass, and here's where the two ends of that calibration box meet up, and we see that they line up perfectly. We'll also see that there's a little bit of a width or height difference here on this side of the box versus the other side. And I found that when this runs this test, this tape builds up a diameter and it allows this to rock back and forth. And when I do this calibration test, this is very common that I see and is perfectly normal. But know that when I do an actual engraving, I don't see this phenomenon at all. My calibration turned out perfectly, and the next thing that I want to check is to see if I need to mirror an image. For this, I'm going to type in the number 2. I'm going to engrave that onto this glass, and we'll find out whether or not I'll need to mirror images when using this rotary unit. I want my number 2 to be facing upright towards the opening of the jar, so I need to grab the corner of this 2, and I'm going to rotate this around. If I press and hold the shift key, it will turn in 15-degree increments, and I turned it in this direction because that is the direction that the opening of the jar is facing. Once again, I'm ready to hit the start button after I put on some safety glasses. Here's the number 2. It's facing the correct direction. The top of the 2 is to the top of the jar, and I don't need to mirror it, and the proportions on the width and the height are correct, and that's attributed to that calibration test that we did with this rectangle. I would say that this video is a great success. Definitely the Atomstack Rotary unit is very compatible with the Ikier K1 series machine. Now we did a quick calibration and mirror check, and everything looks good, and you definitely have some great numbers to start with if you have some small variations in your setup. I didn't really have too many doubts that the rotary unit would be compatible with the Ikier K1 machine, and that's because Ikier is a subsidiary of Atomstack. Ikier carries the performance and extra features under the Atomstack brand name. I enjoy reading your comments down below on different things that you'd like to see on this channel. If there's some other things that you would like to see, definitely leave a comment down below for either myself or other viewers just like you. I hope that you enjoyed this video. If you did, definitely give this video a like, subscribe to the channel, or ring that notification bell. This really helps the channel grow, but more so, it's a great way to connect content like this with viewers just like you. Until we meet again, learn, create, and share.